going to start our class. It's called here marginal analysis here. What is marginal analysis? So this one here, it's about that I have to use the definition of the derivative. I have to use limit h close to 0 if, but I left this after I gave you shortcut formula, product rule, quotient rule, and then you can now use, you don't need to use definition of the derivative. If you go back to chapter 11, they are using the definition of the derivative. So here I try to make it easy because some people, they don't like the definition of the derivative in terms of numerically and algebraically, right? So here, when I solve these problems, just use normal derivative. Just take the derivative any way you like. That's there to make it easy for you. You follow, guys? So what is marginal analysis here? That is called marginal analysis. If I recall, let me recall here from Math 1070 there. If you have C of x, that's the cost function, equal mx plus little b. What is your m? Your m here we call it, I'm just give room for myself here so that I can. All right. So what is marginal? The cost function here is given here, guys. Just try to. So m here we call it marginal. If you recall, marginal, or sometimes we call it variable. Sometimes we call it variable cost. Variable cost, right? Variable cost. And here your b we call it fixed cost. Your b here we call it fixed cost, right? But here your cost function is linear function. Your cost function here is linear function. So now, what about if you have a cost function nonlinear? If you are going to have quadratic or nonlinear cost function, then how you are going to get the marginal cost? What is marginal cost here? Marginal cost here is the cost to produce one item more or one product more. So the marginal cost, what is the definition of the marginal cost? The slope here, or that is our slope, that's linear functions. When x increase by 1 unit, x here number of item or number of product, right? Your x here, number of item or product. So when x increase by 1 item or 1 product, what happened for your c, the cost? That is your m, the slope, or that is, if you recall what I said here last time, 2x plus 1, when x increased by 1 unit, your y is increased by how many units? 2 unit. Why? Because that's our positive slope. Right? So here's the same. Your marginal cost, that is the cost to produce one product or one item more. And I gave you the example last time about laptop, if you recall, laptop here, and number of engineer, right? So if you have increased by 1, then your cost, your function, whatever it is, here in our case, cost functions. So now I'm going to go for nonlinear functions. So our slope or the derivative here, guys, the derivative here, I write the derivative. So C prime, that is, if you have nonlinear at A, what is your A? X equal A. What is X? Number of item or number of product. When it equal, say, A here is a number, then that is kind of measure the change or measure the rate of change. Measure the rate of change. I'm going to give you example of this. Rate of change, right, of the cost with respect to x, with respect to x. All right, guys? So here with respect to x equally, right? When x equal a here, with respect to x in general, that is your derivative. So that is kind of whenever you see how what's the change of your cost or what's the change of any functions, I'm asking about the derivative. How fast the change, also I'm asking about the derivative. All right? So here, if you have a cost function, let me give you one example here, and then I can give you the, if you have a cost functions, here is a cost function C of x equal 150 plus 200x minus 0.002 x squared. All right? So that is the cost here. I have to write the problem maybe. That is the cost, right? That is in thousands of dollars. In thousands of dollars means just in thousands of dollars, right? So that is like scale here. The money will be in thousands of dollars of airing TV. Just a struggle to write here. Of airing TV here. Airing TV, all right?
Sorry.
Yes. Yes.
Is that like 0.002 or?
Yes, minus 0.002 x squared. So 0.002 minus 0.002 x squared. Right? It's bad handwriting here. I'm just right. Sorry for this. So here 0.002 x squared. I need to get what here, guys? I need to get here. What is the question A? Try to find. I have to write so that is kind of TV here, commercial, and the cost function is given by this one. So that's the cost function in dollar of airing TV is given by this function. That is I gave to you. What is the question A? Find the marginal. I need to find the marginal cost, right? And B here, they ask you to find the average cost. Find the average cost. I'm going to explain both of them here. What is the average cost? And the average cost, right? We write C bar. This one C bar like this. You know, I want to distinguish between C prime and C bar. C bar here, that is called average cost. And the other one here, we call it here is the marginal cost. So what is marginal? How to get the marginal cost? Marginal cost here, as I said, I mean the derivative, your slope. How to get the derivative? Here, your cost function is what? Is nonlinear. This cost function is nonlinear. So how to get the slope here? I have to go ahead and find the derivative. I have to take the derivative. So our marginal cost here, just we need to take the derivative, right? So here, they ask you, find the marginal cost. I have to write I haven't write the question completely here. All right, so maybe I should write it here, and then I write the average cost here. Try to find the marginal cost. Where we are here, cost function here, the cost function, and use it. I need to use the marginal cost here to estimate. Use it to estimate. Right? How fast? I should write the question as is written there. How fast the cost is going up? When x equal 4. When x equal 4, right? When x equal 4, right? So when x equal 4, right? So when x equal 4. So that is, I need to get that, how fast when x equal 4 for the cost function. X equal 4 here, that's 4 when x equal 4, all right? So B here, I need to find the average cost. Find the average cost, all right? So average cost, and the average cost, we write it C bar of x, all right? So let me do that one by one, and then first let us find the marginal cost. Here, as I told you, these kind of questions is given, if you look to chapter 11, use the definition of the derivative, limit h close to 0, f a plus h minus f of a over h, and I take f of x like quadratic, but you have to do that numerically. So here, it will be very easy here because the cost function I'm just writing 150, the cost function here 150, right? Plus 1200 x minus 0.002 x squared. So what is the marginal cost? C prime, just go ahead and find C prime of x. You know, you can try with me right here, C prime of x, that is, I need to get the marginal cost. What is the derivative of this? Who's going to tell me how to get the derivative? What is the derivative of 150? 0, very good. What is the derivative of 1200x? 1200, and then minus, what is the derivative of the third one? 0.002, and x squared here, that's a constant, I leave it as it is. Derivative of x squared, just 2x. Does that make sense?
Yeah.
All right, so that is C prime of x. Is that the marginal cost? Not yet, because I have to go ahead and replace x by what? By 4. When x equal 4, your marginal cost, it must be a number. Your slope m must be a number. Remember, you cannot have slope just, you tell me that is the slope, because your x here is what? Is variable. Could be take any numbers. Your x could be take any real numbers. So because of that, in order to get the marginal cost or the slope here, the marginal cost, right? So I have to replace C prime at 4. C prime at 4. So what is C prime at 4, guys, here? C prime at 4 is what? Just go ahead and replace x by 4. So you have negative 0.002, and here you have 2. X, what is X? Just write X, replace X by 4. You have 8. This one 8. Use technology and tell me the number that you have. Almost 2,000. All right. So he said almost 2,000, right? So it's good to write the number that you have. But he said almost.
No.
What did you get?
11.99.
11.99.98. All right. So 11.9. So it's not 2,000 then. It's good to have more than one. All right. So I take this one here. What happened here? So 9.9. Right? Is that the number here that you got, guys?
Yeah.
All right. So now, what is X? I'm asking you, what is X? Number of what? Number of TV, right? If you look to the problem up, what is your X? Here, that is of airing TV, right? So X here, that is the cost of airing TV. So X here, number of TV. Your X here, number of item or product. Yes.
The question is 200x, but you're taking it as 1200x.
Yeah. So here, just let us write. Thank you.
I thought we had it wrong.
You write 200?
Yes,
It's okay. It's okay. Just try to understand what I can, because I'm going to change the number anyway. I'm going to give you. You'll see that I will. but I have, sorry. Yes, some people they are working, right, which is good. But thank you for. It's a good note. So it should be 1,200. That when I start, I should write here 1,200. You see, sometimes I push on my laptop here, but it's not writing. I don't know what is going on there, but I push for the number. You see, sometimes it's not right. You see, did you see? I wrote 1 here, and then disappear. I don't know what's going on there. You see?
Did you actually write it?
Yeah, I wrote it here. So see.
That one's stable.
It's stable. But I hope. But you note, so when I wrote 1, but it's not there. Okay. All right. So I'm writing 12. So sometimes I write the stuff, but it's not show up. But it's okay. It just gets the idea. So now we know X number of item or product or number of TV. So can you tell me, guys, who's going to tell me? When the derivative at 4 equal positive number, what this number means? What is like 1,200? This is almost 1,200. What this 1,200 means? The cost to produce one TV, how much? In order to produce one item, one product more, which is not one TV here, is going to cost what? It's called airing TV, right? So that is airing TV. That's this money here. It's a bare TV. The money here, bare TV. Why bare TV? What is C prime? Let me ask you. What is C prime? DC by what? DC by dx. The derivative DC by dx. What is the unit of C? That's the cost. Should be in dollars, right? Should be in dollars. What is the unit of X? That is the number of TV. So that is the cost. It will be dollars bare TV. Cost bare TV, right? That is what that's come from this one here. All right. So now the cost is going up at rate. Now I could write here the cost. The cost is going up at rate is going up, right? Because it's a positive. Is going up at rate. I'm just writing here at rate almost 1,200, approximately 1,200, right? Approximately here 1,200, right? So now I need to get here, guys. So if you want, I could write here also extra work writing here. So the exact cost, I've just write it here. The exact cost here, guys, of airing TV, right? Airing of the fifth TV. So that is kind of predict the fifth TV. So here, it's not erasing here. I don't know what happened here. All right. So here I should write here, guys. I take this one here out. I should write here fifth TV here. Fifth TV. Why I said fifth TV? Because that's the cost. Like you have when X equal 4 to produce. So you have 4 units. If you try to increase to go for the fifth, the 5 of the, then the rate will increase going up for 1,200. The rate will be increased to 1,200 if you go for the fifth TV, right? So that is kind of the cost to produce one item more or one product here more. It will be here is, so it will be almost here 1200, as I said here, almost 1200. So now what is the average cost? They ask, what is the definition of average cost? So when you say average of something, do you recall from when I tell you what is the average of something, then you tell me, oh, the total divided by the number. The total over the number. So here, the average cost, I'm just define what is the average cost. Is not writing. I don't know what happened here. The average cost here, the average cost is, it will be the total cost divided by number of item or number of product here, number of item or product, right? So it will be, if the total cost is, your cost is a function in C, so C of X, then it will be over X. That is called the average cost. Look what you have, the difference between I write average cost, I write C bar. So C bar here is going to give us the average cost. So what is the total cost here? Just to copy the total cost from what we have. So what you have 150 plus, right, 1200 X, right, minus 0.002 X squared, the whole thing divided by X. Is going to, this one give you the average cost? Yes. Is going to give you the average cost? Yes. So now, if I simplify this, what did you get here, guys? You can replace, they ask you what is the average cost. So if you, how to simplify this, guys? 150 divided by X plus 1200 X divided by X minus 0.002 X squared divided by X. If I simplify this, what do you have? You will have 150 X, and here 1200, because X cancel with X, minus, did I write something here and disappear? 150 plus over X, 150 here over X, and here 1200, right? And here minus 0.002 multiplied by X. So that's the point here. X cancel with X squared, you get 1X. Right, that is your average cost. But here they ask you, what is the average cost at 4? What is the average cost at 4? Because we try to compare what is the difference between average cost at 4 and what is the marginal cost at 4. What is the difference between those two guys, right? So that is the example here. I try to explain the difference between those two guys. Okay. All right, so here, I'm just, go ahead and replace X by 4 and tell me the number, guys, here. Can you replace X by 4 and tell me the number?
1237.
I need more than 1. So here 4. So 1, 2, 3, 7. 4 point. I don't know what's happening here. 1, 2, 3, 4. Right? 3, 7. Yeah. I'm just writing one by one because, okay, right?
Yeah.
So is that what you got here? So that is called here, guys, the average. I'm just explaining what is the number means. The average cost of airing here, the first 4 TV is just 1,237.492, right? You follow, guys? So that is the average cost of the 4. The average of the whole 4, the first 4 TV is, that is the cost to have. So the other one, the cost to produce one item more, but this one, that's give you the average cost of the whole thing because you divide by 4. You follow, guys? Do you have any question for this part? It's an easy one so far, but I tell you what is going to be difficult after I give you exponential, I give you log, I give you all of different type of nonlinear functions, right? And also I could give you the cost function, any fraction. Like you have to use Bauer rule to take how to get the marginal cost, just derivative. How to take the derivative, then you have to apply Bauer rule sometimes, you have to apply product rule sometimes, quotient rule, depend on the function, how difficult is given to you, right? Yes. This one? What do you want? Yeah, you can instead of telling me up.
Like S is number of TV, right? And S equal 4 is mean there have 4 TV. So the price is the price for 4 TV or just 1 TV.
No, x equal 4, that is the number of TV.
Yeah.
When x equal 4 is not, yes, number of TV.
Yeah, so the price we find out there is the 4 TV equal to $11.99 or just 1 TV.
That is the cost to produce the 5th TV, number 5. That is the marginal cost. They tell you the cost to produce one item more. To produce one item more. So if you have 4 TV, you like to produce 5, the 5th, then it's going to cost you 1,200. So the slope, they tell you the cost to produce when X increases how many units? 1 unit. So that is your Y. In our case here, our cost, not Y. So your cost function is going to increase by almost 1,200. All right? But the average cost, that is the cost for the whole 4 TV, the first 4 group, first 4 TV, right? Because you are adding all of them and divided by the number, the total number that you have. If you'd like to get 5 TV, then you replace, it takes the total cost divided by the 5, the total number of item or product that you are going to have. So I try to tell you the average cost is different from marginal cost. All right? So now I try to solve more problem very quick here, because here for this one, chapter 11, it was no power rule, no quotient rule, nothing. It only used the definition of the derivative, and that is why it was easy here, because very much it's a polynomial ones. Look what you have, guys, here. They give you the cost function for number 6, and x between what? 0 to 200. So this one here is called here, guys, what? Domain. Your x here, we call it domain because they define x between from 2. They give you interval from 0 to 200. And what is your x, guys? What is your x? What is your x? Number of item or product, right? So is x must be greater than 0?
Yeah.
It must be greater than 0. So here, that's the reason greater than or equal 0. Right? Because it must be greater than 0 because it's a product or item. So and here they tell you cannot exceed 100. So x between 0 and 100, like this. I'm going to come to that when I come to the application. I give you optimization problems. It's very, very important to have this kind of closed interval because it's like window. You have the graph, and then between 0 and 100, you are going to cut, right? Otherwise, the graph keep continuing from minus infinity to plus infinity. So when I try to limit myself, it's very important. So here, very quick, find the marginal cost. Can you tell me what is the marginal cost here, guys? What is your A here? What is the marginal cost here? Very quick. Go ahead and find the derivative here. Find the marginal cost. You can, all of you here start. So the marginal cost here, C prime of x. So 600 plus x plus 42. X to the power, I cannot see here, x to the power 2/3. The whole thing prime, right? I need to take the derivative of this. I need to take the derivative of this, right? So who's going to, what is the derivative of 600, guys? 0, very good. What is the derivative of x? 1. Here, what do you have to get the derivative of this? 42. And now, it's a constant, 42. And then, what is your n here? 2/3. So I write here 2/3, and the x to the power 2/3 minus 1, right? If I simplify this one here, what do you have? All right. So here I'm just get it. So you have here 1 plus 42, right? So here, if you 42 multiplied by 2/3, x to the power negative 1/3. Everyone 2/3 minus 1, you get negative 1/3. Does that make sense for everyone here, guys? Does that make sense for everyone here? All right. Just to try to see the. All right. So now, who's going to tell me, guys? So that is your A, guys. Your A here. Is that, do you have any question for A here? How to get the marginal cost? Everyone agree? So now, the second question here, what is the marginal cost at x equal 40? And what does represent? Explain what this number means. So C prime at 40 here, I'm just replace x by 40. Replace x by 40. Can you use your technology and help me to get the number here? So you have 2/3 and 2/3 here, 2/3, and just write 40 to the power 40 here. Okay, I just write here 2/3 here, multiply by 40 here, 40 to the power negative 1/3. To the power negative. So can you use technology and tell me the number here, guys? Can you use technology and tell me the number?
94187.
Okay, try to see there is a plug here.